So, I think almost all of you, but not everybody had submitted the homework by the time I had stopped grading last night, and it looked like everybody had gotten this one right. It's something about dynamic reaction, where so the concentrations of the reactants in the products are constant, but the fact that it's dynamic means that the reaction is still going forward. It's just that there's also a reverse reaction that's going at the same speed. So reactions going this way, reactions going this way, and no, you end up with no change. And so there's some equilibrium equations. So I'm going to need a 2 here and a 2 here to balance out the oxygens. And so then we end up with K is equal to dinitrogen monoxide squared divided by the nitrogen gas squared oxygen to the first. All right, so everybody made the same 3 mistakes on this homework, and those are the only mistakes that anybody made. So I'm guessing I wasn't very clear about what I meant when I said something. So these things, what is this? I talked about what these brackets mean. What do these brackets mean?
So the concentration.
And specifically in moles per liter. We okay with that? So if I'm talking about something that's in moles per liter, what are my options? What are the nature of the substances? What are my state options? Aqueous, yes. Liquid, no. Is that it? I mean, we'll just go with the 4. Does it work for a solid? What's molarity measuring? So what's the concentration of a solid in its solid form? 100%. So it's out. So let's say now we have a liquid. What's the concentration of that liquid in itself? 100%. So it's out. So what I'm saying is, since these have to be in moles per liter, the only options for states to be placed into the equilibrium expression are gases and aqueous solutions. So I can't put solids in moles per liter. It's just, what's the concentration of a chunk of gold? It's 100% gold, And in this case, what I have up here is, you guys did this in lab, and well, most of you did this. And then this would be aqueous, and this would be aqueous, and this would be a gas. So that can't be in the equation, because what number would I put in for it? I can't. Is it important for the reaction? Absolutely. It's 100% important for the reaction. But the issue is, this reaction would stop if there wasn't any more zinc. So what we have here is a situation where there is enough zinc and it doesn't take a part in the equilibrium expression because there's enough zinc. So when I'm running through these things, I have to balance the equations for sure, but I also need to check states. And so if I can identify anything as a liquid or a solid, they do not belong in the equilibrium expression because I can't write them as moles per liter. Okay with that? So I was telling them that everybody made the same mistake, so it must have been my mistake. The solid for the zinc, this water is a liquid, can't be in the equation. This water, I wrote it as a gas. Oh, jeez. All right, well, that one's fine. But this water, that's going to be a liquid, and that zinc, that's a solid. Those don't belong in there. So this reaction would cease to be in an equilibrium if the zinc solid were completely consumed, but it's not. It's just sitting there. So we just consider we have plenty of it, unless it disappeared, which in this case it's not disappeared. Does that make sense? I just can't measure solids and liquids in moles per liter because they're not concentrations. Because to have a concentration, I have to have something dissolved in something else or something taking up a certain amount of space. And that only works with aqueous solutions and gases. Doesn't work with the others. So when we write this equilibrium expression, oh, we need to balance it first. I just need a 2 there. Then it's just K is equal to zinc chloride to the first, hydrogen to the first, and hydrochloric acid squared. And that's it. Does not belong in the equation. And so for the next one, same situation. K is equal to hydrochloric acid to the first, phosphoric acid to the first. Oh wait, did I balance this? I don't think I balanced this. We'll obviously need a 5 there. A 4 there. 8, 8. No, wait, let's see. Yeah, no, that's right. So that gives me 8 hydrogens. That's 4 oxygens. That's 4 oxygens. There's 1 phosphorus and 5. Okay, there it is. So then it's hydrochloric acid raised to the 5th, phosphoric acid still to the 1st, and then my PCl5 raised to the 1st. Okay. All right, so the last one down here, we're gonna do a calculation. So we've got K is equal to, we can't have water here because it's a gas. And chlorine, I didn't balance it, 2 there. 2 there. We'll do 4 there. And so then a 2 there. So water squared, chlorine squared, oxygen to the first, and hydrochloric acid to the 4th. Okay, so we'll just throw the numbers in here. The HCl is 1.2 times 10 to the minus 3 to the 4th. The oxygen is 3.8 times 10 to the minus 4th to the 1st. The water vapor or water gas times 10 to the minus 2 squared. I guess I don't really need the scientific notation. Some of these. All right. So do 0.058 divided by 3.2 negative 4. Divided by let's see, 2 sig figs, 1.4 times 10 to the 10th. Okay, so this is an equilibrium reaction, but tell me about the reactants and the products. The products are heavily favored. This is a teeter-totter where the downside of the totter is almost on the ground. It's not going to completion, but I've got a heck of a lot more of this than I do of this. That's it. We're good.